Hi folks, so this is question 5. So we need to show that the derivative of the function is equal to something in this form here. So I think there's going to be completing the square in it. So f of x is equal to 2x cubed plus 6x squared minus 12x plus 3. So the first step anyway is just to find the derivative. So f dash x equals, so you just have to differentiate each part of it. So the first bit will be 6x squared plus 12x minus 12, and then the 3 will just be gone because you're differentiating 3 by itself. So that's the derivative. Now we need to change it so that it looks like something like this. So you can see there straight away that there's an a there outside, so I'm going to take everything out first. So I'm going to take 6 from each of them because each term by 6. So we get 6 times x squared plus 2x minus 2. So it's a little bit closer, but we need to put something in here into the brackets in that part there because to make the perfect square. So I must complete the square in here. So I'm just going to complete the square in here in this bit. So to complete the square, we take whatever is in front of the x term and you divide it by 2 and then square. So divide by 2, then square. That's completing the square. So 2 divided by 2 would be 1, and then you square that, so that's just 1 as well. And then we're going to add on that and subtract it. So I'm going to get 6 times x squared plus 2x, and then we got 1. Okay, so I'm going to add 1, and then I'm putting in my minus 2 next, and then taking away 1 at the end. So we're just adding on 1 and subtracting 1 in there, and that's how you complete the square. And then if you do that, this bit then should be the perfect square. So that it is, so we get 6 outside again, and then in here we get x plus 1 squared. And then we still get the minus 3 outside. So we're nearly there then. I'm going to multiply back into 6 then. So I'm going to do 6 times x plus 1 squared. So that'll just be 6 x plus 1 squared. And then do 6 times minus 3. So that's minus 18. And then that looks exactly like what we wanted back in the question. So it's in this form. So a is... So if you're putting the answers into this little box here, A is 6, and B is 1, and C is minus 18. So that's the first part. The next part then, if g of x is 36x plus 5, find a range of values for which f dash x is greater than g dash x. So we need to find what g dash x is. So that's just going to be the derivative of 36x plus 5. So derivative of 36x is 36. So that's what g of x is, and the 5 is just gone again. So f dash of x then, we can just put our answer to the last part in. So 6 times x plus 1 squared minus 18, and we're just putting it in a greater than sign then, and g dash x is 36. So that's our equation. I just put in what f dash x is and what g dash x is. What I can do here is I can divide across by 6. Each term there is divisible by 6. So if you divide the first one, it's x, you just get x plus 1 squared. If you divide minus 18 by 6, it's minus 3, and if you divide 36 by 6, it's just 6. Bring over the minus 3, you get x plus 1 squared is greater than 9, and then if you multiply out the x plus 1, so x plus 1 x plus 1, you'll get the same thing we had kind of in the first part. We're kind of going backwards now. So x squared plus 2x plus 1 is greater than 1. Sorry, that should be a 9 there, shouldn't it? Don't know why I put in a 1. Bring the 9 across and you get x squared plus 2x minus 8 is greater than 0. Or factorize it then. We'll get x minus 4, x plus 2, no, x plus 4, x minus 2, sorry. So 4 times minus 2 is minus 8, and then 4 take away 2 is positive 2. So we get two answers there. Now if that there was an equal sign, it's a greater than sign, but if it was an equal sign, well then you'd get x plus 4 is equal to 0, or x minus 2 is equal to 0. So that'll be the roots then. So x is equal to minus 4 or x is equal to 2. So if you're to think about what it looks like on the graph for a second, so let's say minus 4 is there and 2 is here. Those are the roots of it. So, and it's a positive quadratic. So if we're plotting looking at what this looks like on the graph, it's going to be something like that. Now, see the way it's greater than 0. So we're looking at all the places that x is greater than 0, so greater than 0 will be up here and up here. So it's all of those points up there then. So the solution is, so x in the middle, it's where minus 4 is greater than x and x is greater than 2. So minus 4 is greater than x because it's all of the things that are left of x or less than minus 4, or yeah, and x is greater than 2 as well. So that will be the final answer. Right, so for part B then, we want to find the value of k ultimately. So this line here, t, is going to be crucial. So we want to find the equation of the line t. So y minus y1 equals m by x minus x1. We want to find that of t. So we need to work out some things. We need to know the slope. So in order to get the slope, I'm going to get the differential of this thing, the hx, and then I'm going to sub in this pi over 6 in for it because we know pi over 6 is on it. So let's get the differential of h of x. So h of x is equal to 2 sine 2x. Differentiate that then. Differential of sin is cos, so we get 2 cos 2x, and we must use this the chain rule. So the differential of what's inside the brackets then of 2x will just be 2. So you're timesing all of that by 2, and then so 2 times 2 will be 4. So 4 cos of 2x. If we sub in pi over 6 then, because we want to know what the slope, we get 4 times cos of 2 pi over 6. And that will just be pi over 3. So that's going to be 2 then when you put it into the calculator. So cos of pi over 3 would just be a half, so half times 4 is 2. So we've worked out what the slope of that line is at that point, at the point where t over 6 is basically. We know the slope of that line t then. So we need to work out a point that's on it. So a point on it will be this point here, but we don't know what the coordinates, the other coordinate is. We know pi over 6 is the x coordinate. We don't know what the y coordinate is, so we can use the original function. The h of x is equal to 2 sine 2x, and we can put in pi over 6 instead of x. So, and then that'll give us what the y coordinate is for that point there. So 2 sine 2 times pi over 6, and then you can use calculator again, and you'll get root 3 in the end. So I think sine of pi over 3 will be root 3 over 2, and then times by 2 is root 3. So the coordinates of that point up there are pi over 6 root 3. So we've got the equation of that line, and it'll be y minus root 3 is equal to 2 times x minus pi over 6. That's the equation of the line, and we need to find what what k is. So we know that the x coordinate is 0, so we can just sub in 0 then, and yeah, we can sub in what k. We can sub in a k for the y as well. So k minus root 3. So I'm not even simplifying that first because I don't really need to. 2 times 0 minus pi over 6. So 2 times pi over 6 is pi over 3, so it's minus pi over 3. And then we can bring across the root 3, so k is equal to root 3 minus pi over 3. And that's it then. You just need to put that in your calculator. I think it wants it to 2 decimal places, so 0.68 when you put it into your calculator. Yeah. So that's it then for that question.